Hi everyone, in this video we're going to talk about Viette's theorem, and first of all let me write the general case for it. And at the end of this video we will try to prove uh, the Viette's theorem for just second order polynomial function, quadratic function in other words. Let's just write our polynomial function, which is px is equal to an x to the power n plus an minus 1 x to the power n minus 1, and this continues till a1 x to the power 1 and plus a0. And this is our polynomial function. And what is our theorem statement? Theorem says that if x1, x2 goes to till xn are the roots of our function px function, then the cases which you will see here are correct every time. First of all, x1 plus x2 goes to xn is equal to minus an minus 1 divided by an. And when we just write the sum but multiplying these two terms and another two terms, and just write the multiplications 2 by 2, we will get n minus 1, n minus 2, I'm sorry, divided by an, and then we will write the multiplications using 3 roots plus x1, x2, x4, and you should just consider that we have written here all the combinations, triple combinations of these roots. And this will go to, for example, xn minus 2, xn minus 1, and xn. And this will be equal to minus an minus 3 divided by an. And this order will continue till multiplication of all roots, and this will be equal to minus 1 to the power n a0 divided by an. As you see, this negative term depends on the number of terms that we multiplied while finding the sum of roots. For example, here we just found the summation of terms one by one. Therefore, this is minus 1 to the power 1, and it's equal to negative. And here it is 2. Our n value will be equal to 2, and therefore with this is equal to minus 1 to the power 2, and this is also always equal to positive 1, and this continues with this way. Now let's try to apply this Viette's theorem for quadratic function which is equal to fx. For example, x squared plus 5x plus 6. And let's just find the roots for this function. x1, x2 be equal to minus 5 plus minus square root our discriminant, 25 minus 4 multiplied by 6 divided by 2. This is equal to minus 5 plus minus 1 divided by 2, and roots will be minus 3 and minus 2. Also we can write and divide into multiplication of two functions, x plus 2. In our case this is possible and easily seen, and you can see here that the roots are minus 2 and minus 3. And let's just first of all find the sum one by one. For example, a plus b is equal to minus 5, and multiplication of them is equal to 6. What Viette's theorem states that if we just find the sums one by one, we should write minus 1 to the power 1, and we should just take the second term in our function, the coefficient of second term, which is not the maximum order in our function, polynomial function, n minus 1. In our case, our maximum order is 2, and n minus 1 is equal to 1, and then 5 divided by the coefficient of this maximum order in our function, 5 divided by 1, and this is equal to minus 5, and is correct in our case. And you can check it for another quadratic equations, or even for the cubic equations, and for all other cases, if you know what are the exact roots. And AB is equal to 6. This can be found that the n minus 2, which is equal to 6 in our case, 6 divided by 1 here, 1, and minus 1 to the power 2, and this is equal to 6, and this is also correct in our case. And why this theorem is correct, let's just briefly talk about this. For example, let's take another px, and with just n different roots, and all of them can be written with the help of this kind of notation: x minus x1, x1, x2, and 2 to the xn are the roots of this polynomial function, x minus x2, and this goes to x minus xn. And then we just multiply and open the brackets, we will get the px polynomial function that we had written at the beginning of this video, this function. And all the polynomial functions can be shown in this form if the maximum power is equal to n, then this polynomial function has n roots, and it can be shown in this format. For also cubic and quadratic equation fx, this is also true: x minus a multiplied by x minus b. And when we open the brackets, we get x squared minus x multiplied by a plus b plus ab. As you see, the sum of the roots are equal to minus this coefficient divided by this one, and the multiplication of them is equal to this term divided by the coefficient of the maximum order in our function. And this is also true for cubic case. You can write and check: x minus b multiplied by x minus c. Again, a, b, c are roots of our function, and you can just write and check what are the different version of summation of the our roots. And this is the end of video. I think it was beneficial for you, and please comment, like, and subscribe to my channel.